Hello, I'm the Chief Executive Officer, Eva Ortega. I'm the Chief Operating Officer, Emma Ortega.
And I'm the Vice President of Marketing and Designer, Jose Lamas.
We are the representatives of Lee Constructions. On behalf of our company, we submit this bid proposal to compete with others to be part of this roller coaster making project for Schlitterbahn at South Padre Island. Put our best team together to work and create the most accurate and safest roller coaster using the best engineers and mathematicians.
Considering the purposes of the public and venue, we have created a fine example of what our team can design and create for your resort for all people to enjoy.
In the following video, we will demonstrate how we designed and mathematically created this safe roller coaster to demonstrate how our team is fully capable of building a safe and creative roller coaster for you. One of the requirements was to start our design at the point 010. Another requirement was to have a slope of 0 at the entrance, so we decided to start with the simple line of a of x equals 10. It's a perfect start for when we do the test run. We decided to stop a of x at the point 110, so our interval is 0 less than or equal to x less than or equal to 1, so that is the first part of our piecewise function. For the next piece of our function, we decided to have a surprise fall right at the beginning, so we connected it parallel with the vertex 110 to a of x, because that is where both functions will have a slope of 0. To form our function, we use a transformation function of b of x equals to a times x minus 1 squared plus 10. We knew that the value of a needed to be negative to have it concave down, and knew that they would make a graph wider or narrower. Since we wanted it narrower, we chose a equal to negative 2. So that way we have b of x equals to negative 2 times x minus 1 squared plus 10. We decided to stop this function at the point 2, 8, so our interval is 1 less than x less than or equal to 2. Next, we wanted the right to keep going downward, so we chose to connect a linear function to b of x. We took the tangent line of b of x at the point 2, 8 to construct our linear function. So we calculated the slope at that point and got b prime of 2 equals negative 4, and used that as our end value in our linear function. Now we needed to find the value of b, so we used the point 2, 8 again by substituting a to c of x and 2 for x. We got that the value of b is 16, so we got our next part of our piecewise function to be c of x equals negative 4x plus 16. We stopped this line at the point 3, 4, so our interval is 2 less than x less than or equal to 3.
Another requirement was that we needed to have the point 42 as a minimum value, so we knew that we needed to connect a parabola to c of x. We used the transformation of a quadratic formula, so we had d of x equals a times x minus 4 squared plus 2. Since we needed d of x and c of x to have the same slope at 3, 4, we used the slope at the point c of x to solve for a in d of x, so we got that a equals 2. So our next part of our piecewise function is d of x equals 2 times x minus 4 squared plus 2 with an interval of 3 less than x less than equal to 5.
As we looked at the function d of x, we decided to stop at the point 5, 4 just to keep the numbers as accurate as possible. We noticed that our next max point was very close, so we tried to create a parabola that had a max at 8, 8, and was smoothly connect to d of x at the point 5, 4. However, after trial and errors, we noticed that this was very risky as the numbers would not be as accurate as we wanted them to be. Therefore, we decided to connect a quadratic function that would pass through the point 5, 4 and have the same slope as d of x at that point. Using the transformation of a quadratic equation, we have e of x equals a times x minus 5 squared plus b times x minus 5 plus c. To solve for c first, we substituted 5 for x to e of x and d of x, and we got that d of 5 equals to 4 and e of 5 equals to c. In order for e of x to pass through that point, we needed c to equal 4. After that, to solve for b, we took the derivative of both functions and we substituted 5 for x. We get that e prime of x equals to b and d prime of x equals to 4. Therefore, b has to equal 4. So we have e of x equals a times x minus 5 squared plus 4 times x minus 5 plus 4. For the value of a, we knew it had to be negative as we wanted concave down, and as we played around with the function, we chose a to equal negative 3. So the next part of our piecewise function is e of x equals to negative 3 times x minus 5 squared plus 4 times x minus 5 plus 4, with an interval of 5 less than x less than or equal to 27 over 5. Once again, we tried to connect a parabola that had a max at a point 8, 8 with the function of e of x, but were unsuccessful because it was very risky. So in order to be safe, we decided to get a tangent line from the point on e of x to get a linear equation with the same slope. We decided to get the tangent line at the point 27 fifths and 128 over 25 from e of x as our next line. So we have the transformation of our linear function f of x equals mx plus b. In order to find our m, we went back to our e of x function and took the derivative. We substituted our point 27 over 5 and 128 over 25 into e prime of x and found the slope to be 8/5. So that is our end value for f of x. To solve for b, we once again used our point 27 over 5 and 128 over 25 and substituted it into our equation, solving for b to equal negative 88 over 25. So our next part of our piecewise function is f of x equals to 8 over 5x minus 88 over 25. We solve this equation at the point 32 over 5 and 27 over 4. So our interval is 27 over 5 less than x less than or equal to 32 over 5. Notice we were much closer to our max value of which we are required to have, so then we needed to construct a function of our next parabola that has a vertex at 8, 8. So using the transformation of a quadratic, we have g of x equals a times x minus 8 squared plus 8. We knew that a had to be negative values as we wanted a concave down. Since we stopped f of x at the point 32 over 5 and 27 over 4, we played around with the values of a and found that when a equals negative 1/2, it intersects with f of x at the point 32 over 5 and 27 over 4. Therefore, our next function is g of x equals negative 1/2 times x minus 8 squared plus 8. We decided to stop this function at the point 10, 6, so our interval is 32 over 5 less than x less than or equal to 10. After finding our g of x, we knew that we had the space between 8, 8 and 15, 0 to design something that the public would really enjoy. We decided to add another quadratic transformation to create a function that would connect to g of x. We used h of x equals a times x minus 10 squared plus b times x minus 10 plus c. And we used 10 since we knew that our function has to pass through x equals 10. So now we need to solve for a, b, and c. To do so, we did the same procedures we did for our function e of x by using the previous equation and their points of intersection. Doing so, we found that c equals 6 and b equals negative 2. For the value of a, we decided to keep a equals 1. Therefore, our next part of our piecewise function is h of x equals x minus 10 squared minus 2 times x minus 10 plus 6. We decided to stop this function at point 11, 5, so our interval is 10 less than x less than or equal to 11.
In order to keep the ride going downwards and having a curve to create the illusion of a wave, we knew we had to connect another parabola to h of x and its vertex, so the slope could be 0 for both. The vertex for h of x is at 11, 5, so our next equation had to be I of x equals a x minus 11 squared plus 5. We needed our function to be concave down, so we left our a to equal negative 1. Therefore, we have the equation f of x equals negative x minus 11 squared plus 5. We stopped this equation at the point 12, 4, so our interval is 11 less than x less than equal to 12. Since we were approaching our final point, we decided to end the section of the right like how we started it. We decided to take the tangent line from f of x to later connect another parabola. We chose a tangent line at the point 12, 4, so we found the slope of f of x at the point was negative 2. Now we have j of x equals negative x plus b. To solve for b, we substituted the point 12, 4 into our equation and solved b to equal 28. So our next equation came out to be j of x negative 2x plus 28. We decided to stop this function at the point 27 over 2, 1, so our interval was 12 less than x less than equal to 27 over 2.
Now we needed to connect this line to a parabola with the vertex at 29 over 2, 0, so that the right could smoothly exit at the point 15, 0. We decided to stop j of x at the point 27 over 2, 1 and connected the parabola there. We also knew that the vertex had to be at 29 over 2, 0. We had two known points for this equation and needed one more to use the method of substitution to find our quadratic equation. Using symmetry, we knew that the parabola would also have to pass through the point 31 over 2, 1. So now we have 3 points to find the equation for our parabola using k of x equals ax squared plus bx plus c. Using our 3 points, we first got these 3 equations that we used for the substitution method. After that, we used this equation to solve for c, which came out to be this, and substituted this for our other 2 equations, reducing them down to be this and this. Using negative 1 equals 28a plus b, we solved for b, which gave us this. We used that to substitute in the other equation, giving us this. This gave us our value for a to equal 1. Knowing that a equals 1, we went back to this equation and substituted a, giving us b equals to negative 29. Now to solve for c, we went back and used this equation and substituted our values for a and b and got that z equals 841 over 4. Now our function came out to be k of x equals x squared minus 29x plus 841 over 4. We stopped this equation at the point 29 over 2, 0, so our interval is 27 over 2 less than x less than or equal to 29 over 2.
Lastly, from here, we just had to connect a line to stop at 15, 0. So the last part of our piecewise function is L of x equals 0 with an interval of 29 over 2 less than x less than equal to 15. This is what our designing team has created using our piecewise function graph. This is our 3D representation.